In 2019, humanity was shaken to its core when we captured the first photograph of a black hole. We believed we had finally witnessed the pinnacle of invisible brutality, a monster devouring all of reality. But the truth is, every single one of us had been deceived. There is a massive flaw in black hole theory that mainstream science has always tried to bury. Mathematics despises the infinity of the singularity. It is a theoretical humiliation, a place where every law Einstein ever gave us collapses into nothing. This precise, elegant universe does not tolerate a crude source code error like that. And the reality is, the universe has already created a perfect stand-in to defeat this paradox. An entity with the power to push back hard enough to dethrone the black hole's dominance. It possesses the exact mass and light-bending force to fool every state-of-the-art telescope humanity has ever built. Yet beneath that disguise sits a macroscopic mechanical structure of terrifying stability. The Gravastar, the gravitational vacuum condensate star. This evil twin does not devour information. It stores it. It does not destroy reality. It protects it. Could the emergence of the Gravastar be the decisive card that shatters every old theory of physics and rewrites an entirely new era? Stay with us as we peel back every layer of this disguised monster right now. To understand why the Gravastar has the power to dethrone the black hole, we must confront the greatest crisis in modern physics, the information paradox. Information. In every physics textbook from high schools to universities, students are taught a sacred foundational principle, the law of conservation. Just as mass and energy cannot be created or destroyed, quantum mechanics holds that quantum information, the fundamental blueprint, the spin and the charge of every particle, are strictly conserved. The cosmos refuses to delete its own data files. Yet Einstein's general relativity demands the exact opposite. It dictates that when a massive star dies, its core collapses into a singularity, a point of infinite density. Think of it this way. Einstein's singularity acts as an infinite cosmic paper shredder. You throw anything in and it completely obliterates every trace of its identity. But according to the law of conservation, the universe requires every single page to be stored somewhere. This is not a quirky puzzle. It is a serious constitutional crisis. The two most experimentally verified theories in all of physics look at the exact same cosmic event and give us directly opposite answers with total confidence. One says the file is permanently deleted. The other says deletion is strictly impossible. Stephen Hawking spent years as the most formidable defender of the position that black holes destroy information. In 1997, he made a signed physical bet with physicist John Preskill: information swallowed by a black hole is gone forever. In 2004, Hawking conceded. He paid with a baseball encyclopedia chosen deliberately because Preskill could extract information from it at will. It might sound unrelated, but the nature of the whole is being shaken. The universe does not delete files. Whatever a black hole does to matter, the information cannot simply cease to exist. Something is wrong with our picture of what lives inside. In 2001, two physicists named Pavel Mazur and Emil Mottola took this crisis head-on, not by patching black hole theory around the edges, but by asking the question. The standard model refuses to ask what if the singularity never forms at all. At the very last moment before the mathematics demands its infinity, something pushes back. Their answer was the Gravastar. And to understand the mechanism, you first need to know something most people never think about, and empty space is not empty. The vacuum. The deep space between galaxies, the apparent nothingness filling most of the universe, is a seething substrate of quantum fluctuations. Virtual particles constantly materialize and annihilate. You can measure this vacuum pressure in a laboratory today. Place two uncharged metal plates extremely close together in a vacuum and they will be pushed toward each other by the pressure of quantum fluctuations between them. This is the Casimir effect. We have measured it repeatedly. Vacuum energy is real, and it pushes. Now compress it. The catastrophic stellar-scale compression of a massive star's core collapsing under its own gravity in fractions of a second. Mazur and Mottola proposed that at some threshold of extreme pressure, the vacuum undergoes a phase transition the same way water reorganizes suddenly and completely into ice at a precise temperature. At extreme gravitational pressure, the quantum vacuum transforms into a gravitational condensate, an exotic phase of compressed dark energy carrying negative pressure. And negative pressure, in the language of general relativity, pushes outward. Imagine trying to crush a tennis ball. The harder you squeeze, the more the spring of dark energy vacuum inside pushes back against you. That force reaches an absolute physical limit, halting the gravitational compression entirely. An unstoppable force meets an immovable object, and the immovable object wins. The Gravastar's shell is composed of a Bose-Einstein condensate. Under normal conditions, atoms behave as individuals, each vibrating at its own frequency, maintaining its separate quantum identity. A crowd of strangers. Cool that material down to 1/1000th of a degree above absolute zero. And something extraordinary happens. The atoms lose their separate identities completely and merge into a single unified quantum state. The crowd of strangers becomes, in the most literal physical sense, one entity. This shell is so thin that a single hydrogen atom beside it would look like a skyscraper, yet so quantum mechanically unified that tearing it apart would require the energy of a supernova. From outside, a Gravastar looks nearly indistinguishable from a black hole. Same gravitational field, same bending of light, same photon sphere. It wears the disguise perfectly, which means we may have been cataloging some of these objects as black holes for decades, without knowing the difference. But in 2024, physicists Daniel Jampolsky and Luciano Rezzolla pushed the architecture further. They proposed the nested Gravastar. Instead of one shell enclosing one region of compressed vacuum energy, the Nestor has multiple shells, one inside the other, alternating layers of Bose-Einstein condensate and compressed dark energy like Russian Matryoshka dolls, except every layer is built from the most quantum mechanically extreme material physics allows. This solves a real structural problem. A single shell under rotation develops instabilities. With nested shells, the tension of the interior cesium dark energy distributes across multiple layers, each reinforcing the others into a structure of terrifying mechanical stability. We have not yet found the exact astrophysical conditions that would produce the Nestor naturally, but the absence of a known formation pathway is not a closed door. It is the most important open question in this investigation. The most significant part of this story is still ahead. Now stop, just for a moment. To feel the stillness of a Gravastar, look at a real mission. The Artemis II crew flew further from Earth than any humans had traveled in over 50 years. At a specific point in the mission trajectory, the spacecraft passes behind the Moon. The entire lunar surface interposes itself between the crew and Earth. Every radio signal cuts out. Houston goes quiet. 40 minutes of complete radio blackout. Pilot Victor Glover said afterward that he wasn't sure human beings had evolved enough to endure what they were seeing. 40 minutes of absolute solitude with the universe, the only home they had ever known, slowly swallowed behind the cold curve of the Moon. The surface of a Gravastar is the ultimate version of that solitude. It has no event horizon. It has a real physical surface where time is bent to the point of freezing, stopping completely. There everything stands still forever across billions of years. An object falling toward the shell would appear from our reference frame to decelerate continuously. Slowing, suspended at the threshold for what our clocks would measure as billions of years. The energy of a dying stellar giant arrested at the last possible moment, preserved in gravitational amber. When matter reaches that shell, the quantum information does not vanish into a singularity. There is no singularity. The repulsive energy of the interior holds everything at the boundary. Every quantum identity spin charge and the full description of what each particle was gets imprinted into the shell, frozen at a surface where time has stopped. The way a fossil encodes the geometry of a creature from 500 million years ago into limestone, the Gravastar's shell preserves the quantum signatures of everything it has ever touched permanently, as an ancient relief carving recording the memory of a galaxy. A black hole is a selfish destroyer of memories, but the Gravastar is a lonely lighthouse keeper. It accepts the reputation of a dark monster to fool humanity's telescopes. But deep inside it is a desperate struggle of space itself to become a solitary guardian, protecting the past from the cruelty of erasure. This is what LIGO is listening for right now. When two black holes merge, the gravitational wave signal has a specific shape, a chirp rising in frequency and amplitude, a sharp peak at merger, then a clean exponential decay like throwing a stone into an empty well. One dull thud in silence. LIGO has recorded dozens of these events since September 2015. Every single one matches the standard black hole template. But if any of those merging objects were nest stars, the signal after merger would not decay cleanly. Those nested shells would reflect the gravitational wave perturbation. The waves would bounce off the layered structure, travel inward, travel outward again, and each time a smaller pulse would escape. After the main signal fades, you would hear a series of quieter echoes arriving at regular intervals, each one timed by the internal geometry of the nested shells. Gravitational wave echoes ringing like a cosmic bell across all of reality. We are waiting to hear that bell. Its sound would prove this entity is real. We have not yet found the formation pathway. We have not yet heard the echo. Both of those sentences end with the word yet. And in science, yet is everything. Our civilization is nothing more than a fortunate accident living in an extremely narrow temperate gap in the laws of physics, a place where no extreme force intervenes, so that we can sit here and contemplate the universe. But life out there is not always this gentle. There are days when the pressure of life, work, and loneliness wants to crush you, makes you feel like you're about to surrender and collapse into a dark singularity. A place where belief and joy are permanently erased. In those moments, remember the Gravastar. In the final millisecond before collapse, the space at its core staged a rebellion, transforming itself into dark energy to push back against fate. The universe did not create pressure to erase you. It created Gravastars to prove that pressure exists not to destroy you, but to awaken the most powerful spring hidden deepest in your soul. We are still listening for the echo, and we are not done. Today's space journey has reached its final stop. If you have any questions, feel free to comment. It could be the topic for our next adventure. Please like and subscribe to stay connected. Keep your sensors open. Our journey continues. Out.